Hello, my name is Nathan Joslin, and I'm doing my code trace for AutoComplete. So the first thing we're just to do is to show the output examples of add all for both the binary and ternary search autocomplete implementations. So given a list of terms, when we put them through add all with the binary search, the result is a sorted array of strings. And this is because binary search utilizes binary search, or binary search trees utilizes binary search. So that's why we need to sort them. For ternary search autocomplete, it's a little bit different. Instead of it being stored into a list, it is stored into a tree type data structure, not a binary search data, not a binary tree data structure, but a ternary search tree. So when we add terms, we're going to start at a common node or overall root, and we're going to organize them like a binary tree, where instead of having just a left and right, we also have a middle. So if we look at the result here, when we add alpha, it's going to start at the root, go to A, L, P, H in the middle, as you see the PHA. We're going to move delta, because delta is not a character equivalent to A. We're going to go right because D is greater than A in terms of lexicography. And then we're going to go down the middle again for delta because that is one whole key. And then for do, we're going to do the same thing. Do the first character is dotted A, so we're going to go right because D is greater than A. And then we're going to go down from D to E, but in do there is no E, so we're going to go right of E. And the pattern continues over and over again. Now we're going to do the all matches. So as you can see here in this little snippet of code, our prefix we are trying to find in terms of matches is do, and our grab, or our current element we are observing in the binary search data structure, is a do. And this is a hit because do and do are equivalent. So we would add this string of characters to the list. Now, the next thing we're going to talk about is a not match. So in terms of a hit and miss. So here you can see that the prefix is do, which is what we're currently trying to find all keys with the prefix do. And a grab, or the current element on it, is pilot. So this is a miss, so will not get added to the list. The same idea applies to ternary search trees, or ternary search autocomplete, where we have the current prefix, or the current prefix that we've sent in is do. And we want to send or return all strings or string of characters that have that prefix. And so in this case, our prefix is doggy or dodgy. So we would return that into, or we would add this to our new list of matches. And misses apply, or misses for ternary search are the exact same thing. If there's a miss, we're going to simply traverse that path until we hit the length of our current prefix. So it's the exact same thing. And in terms of, lastly, we want to discuss the three assertions. So the three assertions do three things. First, the assert equals checks the size of the expected and actual size of the list. So after the operations, we want to check if the predicted or expected size is equivalent to the actual size returned. 2, we want to assert true if the expected list contains all the actual elements we predicted. So this is checking essentially if our expected output actually contains all the values in the actual output. And the second one is just a second confirmation where the actual list contains all the expected outputs. And this ensures that the method is returning all correct terms for the given prefix regardless of order.